Okay, for question 8, they have said the complex number 3 minus I is denoted by U. 3 minus I is the complex number denoted by U. Now they've asked you to show on an Argand diagram with origin O the points A, B, C representing the complex number U, conjugate U, and conjugate U minus U. So let's figure out the complex numbers. U, they've already given you 3 minus I, and next you have to find out the conjugate of U. This is supposed to be what? 3 plus I, since the sign in front of I is supposed to change. You're writing it as 3 plus I. This is the conjugate pair of 3 minus I. So if you know that, now you can find out the you can find out the complex number of conjugate U minus U. So if you do that, conjugate U is 3 plus I and U is 3 minus I. Subtracted and you get 2I as the complex number. Now plot all of these complex numbers on the diagram, on the Argand diagram, and you will get these few points, which is going to be for this A, 3 minus I, A, and then you go to B, which is this 3 plus I, and then you go to conjugate U minus U, which is supposed to be this 2I, and the origin is O. Now they've asked you what shape. State the type of quadrilateral formed by the points of O, A, B, C. Now they're asking you what is the shape formed by these 4 dots. So the shape formed is going to be parallelogram. So if you join it, you're going to get a parallelogram, right? So in that case, your answer parallelogram. Next, B, express conjugate U by U into form x plus iy, where x and y are real, right? So in this case, how do you answer it? You just write down U conjugate by U and try to simplify it. So to simplify, what do? You basically multiply the conjugate of the denominator in both numerator and denominator. So if 3 minus I is the denominator, the conjugate pair of this is 3 plus I. So you multiply 3 plus I in both numerator and denominator to get, you simplify it and you will get 4 by 5 plus 3 by 5 I, right? Yeah. So this is the answer for U conjugate by U. If that's the case, now we can move on to C. So B, they've basically asked you to find out the complex number in the form x plus iy. Is this in the form x plus iy? Yeah, it is. So actually you should write it as 4 by 5. Okay, for C, by considering the argument of U conjugate by U or otherwise prove that tan inverse of 3/4 is 2 tan inverse of 1/3. So what is the point of this question? So they're basically asking you to prove that, let's say we're taking tan inverse of 3/4. Now you have to first find out which argument is 3/4, for which complex number you're getting a theta of 3/4. You also need to find out for which theta you're getting a argument of 1/3. After you find that out, you need to see and prove that tan inverse of 3/4 should equal to tan inverse of 1/3. It's a bit complicated and requires a bit of conceptual understanding. So let's go and solve this step by step. So for U conjugate by U, if you want to figure out the argument for that, you know U conjugate by U is giving you a complex number of 4 by 5 plus 3 by 5i, which is 0.8 plus 0.6i. If that is the case, you can write tan inverse 0.6 by 0.8 oppo by adjacent, and you're going to get tan inverse of 3/4. So you know this is denoting the argument of conjugate U by U. So if that's the case, what is this denoting, right? Now this is for U conjugate by u. That is the expression for u conjugate by u. Now you have to figure out what is defined by this part. So let's see. If, let's say, this is just for the sake of explanation, you may add this in your answer, you might not. It's you can directly go to this, but anyways, I'll still explain it. So the point is, if for u conjugate, right, for u conjugate, which is, let's say, x plus yi, the theta is theta 1. Let's assume the theta is theta 1. How do you write that in this form? In this form, which is another form of expressing a complex number. It's just a different form of expressing a complex number, right? So if you want to express in this form for u conjugate, how do you express it? Let's say u conjugate has a argument of theta 1 and it has a modulus of r1, meaning it has a distance of r1. So you express it as r1 e to the power I theta, right? So you write it as I theta 1. This is your expression for complex number u conjugate, right? Now what is the expression for u? The expression for u could be, let's say, r2, where the magnitude or the modulus is different, the distance is supposed to be different, so we are considering it as r2. How do you define the exponential? I remains as it is, and the theta is supposed to change, the angle is supposed to change, so let's denote it as theta 2. Great. So now if you divide u conjugate by u, what do you get? How do you solve it? How do you simplify it? You use the indices formula, and you will see that when simplifying, r1 and r2 stays as it is, and then you get e to the power of theta 1 minus theta 2 and multiplied with I. So why is that happening? Because if you have powers in the numerator and denominator, you subtract those powers to get the answer. So r1 by r2 remains as it is, and e to the power theta 1 minus theta 2, which is the power of the exponential. So theta 1 minus theta 2 gives you this expression, right? So now we know that if two complex numbers are divided, their arguments are subtracted. This is what we have learned from this long derivation. That is the main point of saying all that. That if you divide two complex numbers, be it u conjugate by u or x by y or whatever the complex number is, the theta is supposed to be subtracted. If you know that, let's find out the argument for u conjugate, which is tan inverse of 1 by 3. Why? Where is u conjugate on this graph? U conjugate is this one, right? So it has distance 1 and 3. So oppo by adjacent, tan inverse of 1 by 3. Tan inverse of 1 by 3. Great. Now for argument of u, tan inverse of minus 1 by 3. Why? Because it is in the negative part of the y-axis. So minus 1 by positive 3, you get minus 1 by 3. Now you can write tan inverse of minus 1 by 3 as minus tan inverse 1 by 3. Why? Because if you look at the curve of tan, it looks something like this. When the theta is positive, tan theta is positive. When theta is negative, tan theta is negative. Therefore, we can bring the negative sign in front because tan of a negative theta is always supposed to give you a negative value for tan inverse or tan theta. You can try this with your calculator and see that whenever you put in a value of negative theta in the tan function, you're going to get a negative value, and when you put in a positive value, you're going to get a positive tan theta value. Great. So if you know that, what have you learned from this part? That theta, the arguments are supposed to be subtracted when the complex numbers are divided. So what is the complex number? Oh, sorry. What is the argument for u conjugate by u? For u conjugate by u, you express it as tan inverse of 3/4. You know this already, but you can also express it as argument of u conjugate minus argument of u. Why? Because we have proven this over here when the arguments are getting subtracted. So let's prove it using that. U conjugate minus u. What is u conjugate? The argument for u conjugate, tan inverse of 1/3. What is the argument for u? Negative tan inverse of 1/3. So the minus gets cancelled out and it becomes positive. So you get a value of expression of 2 tan inverse 1/3. This is how you prove that tan inverse of 3/4 is 2 tan inverse of 1/3. Hence proven. Great. That is question 8. Okay, for question 9, they're asking you to sketch on an Argand diagram and shade the region whose points represent the complex number z, satisfying the inequalities modulus of z is less than 3, real value of z is greater than -2, and the argument of z is going to be between pi by 4 and pi. Okay, so let's go one by one, forget these two parts. Let's start off with modulus of z is less than 3. What does this mean? This means that the distance between origin, where you can say z minus 0. Why? Because there is no other complex number. So this is the origin. So the distance between z, complex number, and the origin is always supposed to be less than or equals to 3. If you know that, the first job is to point the origin. Where is the origin? Over here. You've done that? Great. Now they're telling you that the radius or the distance between origin and z, the complex number z, is always supposed to be less than or equal to 3. If that is the case, you draw a circle with radius 3 and center 0, 0. So I've drawn that. This is the circle with radius 3. Great. That is the first part. Done. Next, you have real value of z, meaning if z is expressed by x plus yi, the real part on the x-axis, if this is the imaginary and this is real axis, the real part of the expression of the complex number is supposed to be what? Greater than -2. So you draw a line, y is equals to -2, and shade the increasing part, this part. Now it's not done yet. So there is another limit, which is the argument of z is going to be between pi by 4 and pi. What does this mean? This basically means that, first of all, z can be anywhere. If I draw it again, right? So first of all, they've given you the condition that z could be anywhere in this circle, considering you're still not answering this inequality. So if that is the case, you know that z can be anywhere in this shaded region. Granted, you're still not using this inequality. So now from this shaded area, they're telling you that argument of z can be anywhere in this shaded area, but it should make a theta or argument of pi by 4 to pi. Meaning, Where is the argument going to be? Pi by 4. It's going to bisect this quadrant. It's going to bisect this quadrant like this. And where is pi? Pi is supposed to be over here. Meaning, after considering the inequality, the z, complex number z, can only be in this part of the circle, where z can make a theta of, or argument of, either pi or to pi by 4. So it should be able to make an angle or argument between pi and pi by 4. That is why we draw the circle and shade this area. Great. So that is question 9. Question 10. So for question 10, they're telling you, solve the equation z square minus 6i z minus 12 is equals to 0, and give the answer in the form x plus iy, where x and y are real and exact. So basically they're telling you, use the quadratic equation and solve for z. You basically use the quadratic equation, plug in the values of a, b and c, and you'll get 3i plus minus root 3. So if you organize it in the form of x plus yi, you're going to get root 3 plus 3i. That is your complex number, and the conjugate pair minus root 3 plus 3i, or the other way around, whatever. So these are the two roots of the quadratic equation, both of which are complex numbers. Great. So if that is the case, the next question asks you, on a sketch of an Argand diagram with origin O, show that points A, B representing the roots of equation in part A. Okay, so they're asking you to plot these two complex numbers. So if you plot it, first is minus root 3, and 3i, where imaginary value of 3. So this is A, and the other one is root 3 plus 3i, root 3 positive 3i. So A, B. Great. These are the two complex numbers. You have sketched it. Next, find the exact modulus and argument of each root. So they're asking you to find the distance or the magnitude of R, meaning the distance between A and O and the distance between B and O. Right. So if we start off with the modulus, we can say R is supposed to be root 3 square, or if you take this, root 3 square, which is 3, and plus 3 square, which is 9, all under a root. Great. So you will get the distance to be 2 root 3. You're basically using Pythagoras theorem to find the distance OB, and this same will apply to A, since both of those are have the equal magnitude. Great. Or you can also separately find out R for OA, your wish. Now they're asking you also to find the argument. Now, is the argument for A and B going to be equal? No, it's not going to be equal, because B will make an argument of this and A will make an argument of this. Great. If you know that, now let's move on to the next part, which is asking you to find the argument of B and A. So how do you do that? First, let's find out the argument for A. So there are a few ways to do this. You can find out this part and then get the argument of B. Then the other way to do this is find out the argument of A, I mean theta of A, this theta, and then add with 90 degrees to find the argument of A. So if you do the second approach, you know that if you draw a triangle like this, representing the triangle A, let's say this is D, A, D and O, this theta can be found out by tan inverse of oppo, which is AD, which is supposed to be root 3, and the distance of this, which is supposed to be 3. So now you can find out tan inverse of opposite root 3 by 3, where you can omit this minus sign because you're just trying to find out the theta. You don't need the minus sign. So now you have tan inverse of root 3 by 3. Now the theta that you get is pi by 6. So this theta is pi by 6. So the argument of A is supposed to be this theta plus this theta. This we know is 90, or rather pi by 2. And this we just found out is pi by 6. So if that's the case, we can find out the argument of A by adding both the angles, both the thetas. So you're going to get argument of A as pi by 2 plus pi by 6. So you're getting 2/3 of pi. This is the argument of A. What is the argument for B? For B, it's sort of the same, where you know this theta and this theta are equal since they're making the same distance from O. This if is pi by 6, this is pi by 6 as well. So if this is pi by 6, what is the argument of B? Is simply pi by 2 or 90 degrees pi by 2 minus pi by 6, and you will get the argument of B. Great. So if you do that, you're going to get pi by 2 minus pi by 6, pi by 3. These are the two arguments, and this is the modulus. Okay, next part. Hence show that the triangle OAB is equilateral. So basically they are asking you if OA and B is equilateral. Yes, it is. Why? Because they can look into your diagram and try to draw a clear and accurate sketch so that they can understand that you understood that it's an equilateral diagram. And how do you answer it? You can say that AO is equals to OB and is equals to AB. Or you can say all the angles are pi by 3. Since you already know that, why are all the angles pi by 3? Since this is pi by 6 and this is pi by 6, pi by 6 plus pi by 6 is pi by 3. So if this is pi by 3, this is pi by 3, and this is also pi by 3. You can also prove that, but I don't think for 1 mark you need to do all those steps. So yeah, that is question 10. Great.